Welcome. We're continuing with agent programs. The agent programs, we said there are quite 4 of them, and previously we looked at the simple reflex agents. So moving on with let's look at the module-based reflex agents. The most effective way to handle partial observability is for the agent to keep track of the parts of the world it cannot see now. The idea is for the agent to be able to, we want to improve it, to increase accurate from the simple reflex agent one that we described before. So for it to be able to do that, the agent should maintain some sort of internal state that depends on the perceived history, thereby reflects at least some of the unobserved aspects of the current state. So the idea is for the agent to have internally and part of its persisted items, there should be information regarding the state. An example is of the breaking problem that we described, that we were moving on from before. Example, the internal state is not too extensive, just the previous frame from the camera. So the internal state should allow, for example, the previous state, what if the previous camera perceived in case maybe there was a vehicle moved and it had switched the stop lights, allowing the agent to detect when 2 red lights at the edge of the vehicle go on or off simultaneously. So this is a simple situation where the agent simply, for it to initiate the braking sequence, is to check whether the front have initiated the brakes. So what it will need to do is to just take note of that perception. So but there are other driving tasks now, such as changing lanes. The agent need to keep track of where other cars are. If it can't see the other cars, it needs maybe some sensing equipment too, so that it knows that the front and the behind and the side cars where they are. So, and in case of any driving to be possible, that is for it to be able to start driving car, the agent needs to keep track of where the keys are. So the idea behind the model base, or what's being introduced here, is that the agent need a way to keep a model, so that it can have some information, more information other than the simple reflex one. So this internal information now needs to be updated. So updating this internal state information as time goes as time goes, the agent will require a certain kind of knowledge. That is 2 types of the knowledge to be encoded in the agent program. First, we need some information about how the world evolves independently of the agent, without it affecting it, how the world evolves. For example, that an overtaking car generally will be closer behind than it was a moment ago. Second, we need some information about how the agent's own action affects the world. For example, if the agent is to turn right, it should understand that the car goes right ways, left goes left ways. Also, the agent should know that as it's driving, the car is moving and the coordinates are changing at a given point in time. So the knowledge about how the world works is called the model. This knowledge is the one that is called what? The model of the world. So an agent that uses such a model is called what? A model-based agent. You can now see that the main difference between the previous one, which we discussed, is the simple state, the simpler one, which we just look at the state. But this one now, it keeps a model of the world, the knowledge about what the current and how the world works. So this is the structure. It's quite similar to the reflex agent in that the sensors will interact with the environment. This one will represent the internal state. What is the world like now? But the difference now comes that there is a state and how the world evolves and what my actions do. The agent now have all this information as part of it, and the conditional action rules. So most of this is similar, but this one is incorporates these items. So this one is an example or the skeleton of the program of such an agent, whereby it will take in the percept and returns an action. But the agent now have got these 4 items as part of the model now, where the state is the agent's current conception of the world state, the model, the description of how the next state depends on the current state and action, rules, set of condition or action rules, the action, the most recent action, and none. So these 4 items are just basically they're just the state, and there's a more interesting function which is now in this agent, this function called update state, which will look at it keeps on updating the internal states by looking at the current and the action and the percept, like that. Then it returns the action. So the other form of agent are goal-based agents. So this one it goes also a little bit improves from the model-based one. Knowing something about the current state of the environment is not always enough for one agent to decide what to do. For example, at a road junction, the text can turn left, right, or go straight to the correct, but the correct depends on where the text is trying to get. Like, there is now a goal here. It's not just a matter of driving or going, but we need to know so that we can reach the passengers what destination. That's the goal. So as well as the current state description, the agent needs some sort of goal information that describes situations that are desirable. For example, being at the passenger's destination, that's the most desirable goal. So you can see that this agent improves on both the simple reflex and the model based. So search. So this one involved 2 most important subfields in artificial intelligence, that's search and planning. So because the agent have to find an action of sequence from sequences that achieve the goals. So the reflex agent now, for example, if it was just an example of driving, the simple reflex agent, what it will do, it will brake when it sees brake lights. But this one, the goal-based now, in principle, it could reason that if the car in front of has its brake lights on, it will slow down depending on how to achieve its goal. So this one it's a simple structure, but rather than it adds on now. So it will add on a little bit more on the internal state. That is what the world is like now. Then what if it will be like if I do certain action, whether I turn left or right, then what action should I do now to maximize what the goal? So there will be goals. So based on these goals, the action is taken on. Like the model, it has got state, how the world evolves, what my actions do. So it will involve this in function which will keep updating the internal state. So the agent keeps track of the world state as well as set of goals it is trying to achieve, and chooses an action that will eventually lead to the achievement of its goals. So we can have such an agent improving more and trying to achieve what is goal. But again, it's not sufficient just working with a goal in mind. The goal alone might not be enough to generate high quality behavior in most environments. For example, many action sequences will get the text to its destination, but some are quicker, safer, more reliable, or cheaper than others. So we come up with what we call a utility function. The agent's utility function is essentially an internalization of the performance measure. So we want to try to improve or maximize the performance of the agent. So that performance, it's like it will be implemented, which we talked about initially. So the model-based utility-based agents looks like this one. The internal functions. We have other more items like what the world is like now. What will it be if I take actions? It also understands what will happen if it takes action. Then after taking that action, how happy will I be in such a state, and what action should I be now? So these are additions to the utility-based agents. We have other things is before the state, how the world evolves, and what my actions do, and the utility. All these are the information that will be used in decision making. So the utility is the function that will try to maximize, right, the performance. So this one uses a model of the world that is how it knows what's the world like. It represents, like it perceives, so that it can be able to learn and predict, along with the utility function that measures its preferences among states of the world. Then it chooses an action that leads to the best expected utility, where expected utility is computed by averaging over possible outcome states weighed by the probability of the outcome. So basically what we've managed to do here is we have looked at the agent programs. We now have a structure of the skeleton agent programs which we can have. This gives us a good understanding of implementing these agents, and we'll move on to discuss the learning agents, and we'll get a more understanding of the agents. Thank you.